Okay, so I have 2030 UTC, so let's go ahead and get started with our second part of the DPRIVE meeting for IETF 111. This is going to be focused on two of the newer working group items that we've been discussing. So the first one up is going to be Ecker talking about the authoritative recursive to authoritative servers. Are you ready, Eric?
Am I doing these slides or are you? I guess you are. That's
yes,
cool.
Tim will move them for you.
No problem. Sounds great. Okay. So I guess as people know, we proposed this draft at the last IETF, the very last minute, that was basically trying to do the authoritative case. Next slide, please. So, like, sorry about the goofy name. There was some confusion about the latest tag, which gets stuffed in by Martin's tools and then is not actually supposed to be part of the name. Anyway, so I mean, this is like kind of the obvious thing, and we talked about some of this earlier, which is it defines how to do authenticated recursive authoritative with the assumption that the authoritative has got some credential, whether it's WebPKI or Dane or whatever, and it uses the SVCB record, and it depends on signaling in the parent server. And while we think there's some value in being able to have signaling outside, that there are a very large number of cases where if you don't know at the time you meet the initial connection, you're not going to get the security you want. And the draft goes into some detail about why we think that's the case, but I think there's like not too much dissent about that. Next slide. So there's quite a bit. There are four major classes of concerns raised here. I think I've bolded the one that I think is the most salient, which is the practicality of the child SVCB in the child being propagated to the parent. And because, as I said, you want to know at the point where you connect to the child server that you expect TLS or docs. Then you need some indicator there, or things kind of don't work as well as you would hope. And there are a number of concerns raised to the practicality of this. Paul's Rudo's going to be talking about this in like excruciating detail, so I'm going to bracket that mostly. There are also some concerns raised about the authentication mechanism, whether it should be WebPKI or Dane or both, what kind of transports we ought to allow, dot versus dope versus doke, and also can we encrypt to the root like at all, which isn't necessarily a requirement, but is attractive. In general, this kind of system works a lot better if it's like TLS all the way down. Next slide. Okay, well, this is a bad slide. I apologize. I just started reading the last point. So as I said, we use the SVCB record to signal that you should be expecting TLS. This seems like a challenge in the short term because of the ability to get the SVCB into the parent. Ben Schwartz and Warren Kamari resurrected this draft, which defines how to use the NS record to kind of hack around this now. You see I have should work now. I believe Paul thinks it shouldn't work now. So I don't propose to, I propose to let him cover that, not me, but I just wanted to bracket that so people didn't think that, I was getting out too far of my skis here. I hadn't seen Paul's slides. There's some sentiment that's not the right long-term answer, but I think there's also a fair amount of sentiment that is the right long-term answer. So this like last bullet point is not amazing. But I think it's clear that like the short-term answer is not amazing. Okay, next slide. I think this slide, I think, as I said, there's some confusion about like Paul versus my talks. But the way forward that I'm proposing is the following. We adopt this draft. We need a for now answer for signaling, and I think that we were intending to point to draft Schwartz rather than incorporate it. There have been talk of incorporating it. I think Ben suggested we just point to it. I think that we prepared to, and then the other open issues that we've actually discussed after we've adopted the draft, because the idea is to get the stake in the ground where we do something. So I think we should be prepared to remove SVCB in the parent entirely if we have to, if we come to the conclusion it's simply never going to be viable. And then I think the remaining issues, these questions about which transports we support or what the authentication mechanism are, seem like ripe issues for working group discussion, but don't like necessarily shouldn't get in the way of deciding what we're generally going to do. And eventually, we can argue with them and take a home or whatever. I think, taking a step back even perhaps from this, I'd like us to work on this case. I'd like to get to the point where we persuade ourselves that it can be solved, and then work on solving it. So I think, I think we agreed to have all discussion except for clarifying questions after Paul had presented. But I think what I'd like to get out of this discussion is, do we think this cannot be solved at all? In which case we could just pack it up and not work on this, or do we think it can be solved? And then what would be the minimum showing of doing that and the minimum direction forward to be the point where we're going to sort of actually do that work as opposed to debating where that work can be done, which is where we are now. So I'd love to get that soon, because like if this can't be solved, I have other things I want to do, and if it can be solved, I want to get it done. So I think unless people have questions about like anything I just said that seems unclear, I suggest we let Paul present. Paul Huffman. Oh, and Paul Reuters.
First alphabetically. So I wasn't clear, Ecker, with what you were saying the problem was. Can you repeat what you think the problem is at slightly less than half of an Ecker?
Sure. I think the problem to be solved is an authenticated connection to the server in a way that before you connect to the server, it should be authenticated. It should be authenticated. So what I assume is, like, I go to com and I say, I want to resolve example.com, and it hands me an NS record and some other nonsense, which tells me that if I go to example.com, that that I'll be able to encrypt it. Paul Reuters, sorry, go ahead. Can't hear you.
Weird. Okay. There seems to be a bug if you select the microphone once, it doesn't work, but then unselecting a second again works. Anyway, just for me a clarification, because I'm not entirely sure if you think that, let's say SVCB at parent wouldn't work. I think everything else would still be worth doing in the SVCB, in the ADOCS document, because I don't think the protection of the name server that's in Bailiwick is that important. And I don't think that there's much to be gained from finding out the right name server name, and that is too revealing about the domain name itself. So I think even if SVCB in parent and draft Schwartz deprive name signal would not be feasible, I think everything else still is useful to do. And then maybe find another better way of doing what these two things are doing. I just want to clarify. Right. I think everything else is still good. I think SVCB in general to convey this information is good. And I wouldn't want to see that all go away.
Right. I'm getting echo. Sorry, it's been a little late in the day for me, but or early or whatever. But I don't think it's a matter simply of in Bailiwick, but I think it's a matter also of protecting it, which is to say that absent DNSSEC, if the parent doesn't tell me I can encrypt to the child, then the attacker can force me down in an unencrypted posture, and so even out of Bailiwick records, I don't get privacy. So I think if you're prepared to assume universal DNSSEC, yes, you're correct. But if you are not prepared to assume universal DNSSEC, which I'm not, then I think you actually need the parent. So if I'm wrong about that logic, let me know, or do we just disagree about the universal DNSSEC piece?
Sorry, yeah, I think you're wrong there, because if I have securely resolved ns1.dreamhost.com, then if I get for another domain and I get the NS record ns1.dreamhost.com, then what else do I need? Like I already know the keys to that name server, so I can already set up my encrypted authenticated channel. So there's no issue for that target domain that it doesn't have an SVCB in the parent.
You mean if I'm cached? So I guess I'm assuming I go to example.com and I ask for foo.com, right? And it says foo.com is it ns1.dreamhost.com, right? But then how do I know I can encrypt the connection ns1.dreamhost.com?
So I'm assuming that you've already looked up ns1.dreamhost.com before for other domains, and you already have that information. And at some point, maybe you leaked the information that you were looking for ns1.dreamhost.com when you were looking up dreamhost.com, but who cares?
Okay, but on first impression, but if I'm totally cold, that won't happen, right? Okay, I guess I think what you're saying would have some value, but I think it would have less value than having a parental signal.
Okay, let's move on. Brian Dixon.
So I'll start off by saying, Ecker, you're wrong. Let's first say, okay, the in-bailiwick case, where the name server's name, the zone is being served by a name server that's in the zone itself. That will never have privacy modulo some serious upgrades that are going to take decades. That's never going to happen. If we ignore that case of the in-bailiwick name server, then the real issue is that when you're looking in the COM zone for the name server for example.com, and it gives you a name server of ns1.example.net, the issue that remains is how do you make a secure or how do you validate the glue data for ns1.example.net? And currently that is not possible. The NS records and the glue A records, if they're there, are not signed. So that's an issue that extends beyond just ADOC. It's a large issue, something I'm going to tackle in DNSOP, but it's separate. And once that's solved, then connecting to or making a query to ns1.example.net for something that's DNSX signed, whether it's the TLSA record or some other thing, to tell you how to make the query to ns1.example.net for example.com. That's the piece that you want to have TLS on, but that's a solvable problem without requiring signaling at the parent.
Well, I think this is what Paul and I were just saying, which is you're assuming that ns1.example.net is DNS signed, and I am not.
We can make it a requirement. It's a reasonable requirement for scale.
Well, I don't agree with that.
And without that, I don't think you can
that is the point of contention.
But without that, I don't think you have any way other than on the parent, and I don't think the parent is viable.
Okay.
The DNSX signing of ns1.example.net does not require that example.com be signed. Those are orthogonal.
I understand that point.
Okay. There, fair. Okay.
All right, Victor.
I want to add one thing. I'm also skeptical, but we'll discuss that later, about the viability of parent-side signaling of the sort that you're envisioning. But one thing we haven't discussed is the possibility of putting signaling not in the forward namespace, but in the unavoidably leaking IP address namespace. That is, when you discover the IP address of the name server, the signaling for whether to use TLS there can come from the ARPA zone, which can be signed and so on and so forth, and does not leak even in the in bailiwick case what the actual domain is that you're looking for. You're wondering whether an IP connection to this IP address on port 53 should be TLS or not.
I don't think I feel equipped to address that point. I think if a number of other people feel that way, then we're not. Then adopting this draft would be premature.
Okay, Peter.
Hello there. Can you hear me?
I can.
All right. First, Paul Wouters said if foo.com is on DreamHost, and therefore you have cached that DreamHost has DOT or DiskKey, etc., and then bar.com is also on DreamHost, you can reuse that information. An attacker that is on path might change the delegation information for bar.com because it is not DNS authenticated. point you to dreamhost xx.com or whatever, and give you the same IP or even a different IP. So you still have a hole in that whole flow. And as for what Victor said, tying everything to the IP, it has the same problem. The glue data is also unauthenticated. So neither of those completely solve the problem, even on a hot cache. Thank you.
So I'd assumed the connection to the parent was encrypted, as Paul was saying on Jabber, because otherwise I don't see how this works at all. But maybe I'm misunderstanding you.
If the connection to the parent is encrypted safely with some authentication, then none of what I just said is relevant. Correct. But so far, I've been assuming that .com will not be going along for a while.
So yeah, I think what I mean, this is like the security logic behind the design that I have in mind is not too dissimilar from the sort of like from the sort of HTTPS design, which is basically as long as you have as long as you start somewhere secure and you have an unchanged set of links that are encrypted, everything is fine. But if any of those links is unencrypted, then it breaks down. So the way I'd assumed to fix the, I mean, I was hoping the way we fix this problem. So I think that the two LDs will have the TLDs will have to be encrypted, or this isn't going to work. But the root of these, you could imagine not being encrypted and having the TLDs individually be encrypted and have the clients, the recursive memorize that somehow. I'm happy to have both. Chairs, by the way, cut this off. Paul saying it makes sense to have this presentation, and I'm just responding to questions. So like, let me know when you want me to stop.
Yeah, we'll cut the mic line at Daniel, and then we'll transition over to Paul's talk.
Okay, so yeah, I agree. The root is uninteresting because you can download the root, zone verified, etc. But expecting the TLDs to encrypt is a big ask. And I fully agree that everything you're saying will work if they agree to do that.
Sure.
But
Well, I think right. Well, I think if we can't get the TLDs to encrypt, we have a big problem anyway, because so many of the resolutions that are sensitive are the 2LDs. So if my connection to .com isn't encrypted, then I just leaked that I was where I was going in the first place. So even if we didn't, even if we only were at the first hop, we still have a problem. Mr. Hoffman?
Yep.
So two things. First, to the point that you just made, Ecker, Scott Hollenbeck talked at the last IETF meeting here, saying VeriSign is going to be very conservative, it's going to take a long time and such. If you do just a quick look at the NS records, at random NS records, the vast majority of them end in com or net. And so you may be optimizing for that. Going back to a thing that Victor said, though, which is, oh, well, maybe we can use a reverse tree. DNSSEC signing sucks in the forward tree, and it sucks even worse. I'm sorry, deployment of DNSSEC signing sucks in the forward tree, and it sucks even worse in the reverse tree. So if you look at random domain names, not using a most popular list, but even looking at others, we're talking about 4%. So it would, in my mind, be odd for this working group to adopt a working structure that just could not be deployed unless DNSSEC deployment got a lot better. ICANN has been really, really trying to get people to do DNSSEC deployment for a long time, and we've basically leveled out. So, and I believe that would even be worse in the reverse tree, going to what Victor was talking about. Thank you.
Thanks. I was unclear about that, so thank you. I guess maybe we're taking a step back. I've heard a number of times people say they don't think that the TLDs will do this. That may well be true, but I think if that's true, we should abandon the entire project, because like the amount of value we're going to get if all that happens is that example.com is that you can protect people from whether you're dereferencing ns.example.com or foo.example.com, like, seems extraordinarily marginal. So like I'm certainly hoping that something will happen here, but like if I knew for a fact that like no major TLD would do this, then I would just pack up. I don't have to worry about any of these other mechanical questions, because if they're not even going to encrypt their own links, then it's hopeless. DKG?
Daniel Kahn-Gilmore.
You're very difficult to hear.
Okay. Hopefully this is a little bit better. So I agree with you that if none of the TLDs are willing to do this, this is a lost cause because that's where most of the sensitive information is. But if even one of them is willing to do it, I don't think this is a lost cause, right? I mean, this is a differentiating factor between TLDs, and I could imagine if you were operating a sensitive network service, wanting to move to a TLD that does support this as part of your, as part of your plan going forward to protect your user base. So, I don't think we need all of them to support it immediately out the gate. I think we just need to be convinced that there's at least one that would be willing to adopt it in the relatively short term to make it worthwhile. As far as the reverse zone, I think there's even more problems besides lack of DNSSEC deployment in the reverse. There are a lot of name servers that are out there that are referred to by multiple names, and it's not at all clear that if you're doing this sort of signaling on that endpoint, that all of them will have authentication at the same time, particularly if we're talking about authentication being named authentication. The certificates that are on offer may support name X, but not support name Y, and both of them are used. And if we say that you can only signal based on the IP address, you're effectively saying that to signal hard fail for one of the names that this name server is known by, you must inflict hard fail on all the other names this name server is known by. And that is not a viable deployment option.
Okay, so why don't we go ahead and transition over to Paul's presentation, and then that way we can reserve the rest of the meeting to discuss some of these more larger scale points. So Paul, are you ready?
Okay, next slide. So just a quick overview. So I'm talking about two drafts, drafts that Ecker was just talking about, and a draft that he mentions, draft Schwartz DPRIVE name signal 00. So I won't have to explain what they're doing because that's just roughly explained. So next slide. So I just wanted to list all the problems that we would have to solve to get SVCB records served at the parent, which is kind of at the wrong end of a zone cut, so that needs special processing. So either this is going to be a new type of glue record, that is a copy of what lives at the child at the parent, that you can then verify at the child if you want to, or it's a record that only lives at the parent and not at the child, such as the DS record. Both have their own set of issues. First of all, you need to update all the major DNS software. You need to deploy this at the TLDs and everywhere else. Then you need to update the recursive servers everywhere. And then the application somehow must be sure not to use this standard DNS resolver path that might leak to might lead to unupdated software and starts leaking. So then it would have to do like some special lookups to make sure that it's using only the new servers. This is going to, in itself, is going to take a long time, and I don't think this is something that we can do. Like I said, 10+ year problem. I think that's really the case. Next slide. Next, but nobody's talked about yet. If you want to put anything new at the parent, then you also have to update the EPP protocol, for which I did not see a draft submitted yet. If you have an updated EPP protocol, like a new extension, then you've got to have that deployed at the registries. You have to get it deployed at the registrars. All the registrars and sub-registrars have to update their web portal, which is often the way these records are started and make it out to the registry. And then we run into the same problem we had with the DS and the DNS key records, that basically the registrant needs to update this information because they're the ones who are allowed to update the registration, but they don't know what they're talking about when you tell them that they need to put an SVCB with this large string text into somewhere. So you'd have to have the same sort of automated mechanism like CDS or CDNS key or C-Sync, which could probably be used for it, to do that. So you need that deployment as well, which would slow things down a lot too. C-Sync would be able to already do it in the current specification because you can give a bitmap of record types that need to go up. But I don't think C-Sync has seen any deployment. So next slide. So I think, the working group has two choices. Either we're going to say SVCB at the parent is just not going to happen, and anything that we define as an interim solution will become the permanent solution, and we just live with that. But we make that choice actively. Or we're going to say, well, we're going to run like this as it is specified, but then I think what will happen is that browsers will start using only trusted, up-to-date DNS servers that have been updated. It will still take a long time because of the TLD server upgrades that need to happen. And I see that further leads to more DNS server centralization in general, and maybe even a splitting of, browser DNS and other DNS. And I think that's not good. So I would like to just solve the problems while we know that these problems are there. Next slide. So the interim solution, this has actually been talked about quite a bit. So just for the people who aren't aware, the solution is to basically encode the SVCB content into a fake name server name in a clever way that it fits and publish that at the parent. Now this goes back to the DNS curve hack from DGB, right, where he was going to have his curve 24519 key encoded in the name server record name. But there's a number of problems with it. The biggest problem is, even if this all would work, is that if you have a name server and you have tens of thousands or hundreds of thousands of domains associated to that name server, you will never be able to recycle your key into something new, because you can never get all your customers to update that name server record unless you fully control the automation of that path. It is very unlikely that you can ever upgrade your key. Further, the NS at the parent is glue, so it's unauthenticated and unsigned. We already discussed this a little bit before. The thing that we didn't talk about yet is that a sort of rogue TLD could actually put this glue in there, pointing to its own server, and still happily serve everything, but get a copy of all the records that people are querying about, and basically create like a nation-state man-in-the-middle type infrastructure by simply adding some unsigned NS records to their zone, which I think sets the bar really too low for people to start doing man-in-the-middle attacks. ISPs or coffee shops could do the same thing and bypass this path, which I don't think it's a good path forward. We have talked about this in the past with Peter van Dijk and in the working group as well, about encoding something like this in a DS record. What is the advantage of the DS record is that it is actually signed by the parent. It is authenticated by the child because it came in through some authenticated mechanism like EPP, or maybe CDNS in the case of the child uses DNSSEC in the zone and these mechanisms. So there is a method of transporting new kind of DS records. There is some leeway that unknown or unexpected DS records that you don't really know how to process, you're supposed to ignore, and you can then pick the other one that you like. So it shouldn't interfere with the current DNSSEC resolving for which the DS record's actually used. So you could probably, overload it and store that same information encoded there. It should require no DNS server software update, and it is also protected with DNSSEC. If the child really cares about this being authenticated and it uses DNSSEC, it can actually put a CDS record in the child so that anyone querying can confirm that the parent data is actually legitimate and conferred by the child. So then a rogue parent will not have to just insert an unsigned record. They actually have to insert a signed record, which they go on record for proving that they have abused their power. Or alternatively, they have to nuke the entire child zone and take the whole child zone over to man-in-the-middle then. So I think that's a much better scenario than using the NS record. So I think that's mostly it. So I think we can go back to the original discussion, and I'll give it back to the chairs.
Okay. Watson, you're first in the queue.
Hello, Watson. Thank you. I didn't realize this first. This presentation has made me very sad about the prospects of deployment here, which I think was the intention. I do want to push back against the idea that we should expect resolvers never have to change a thing. Resolvers do need, especially recursive resolvers, are going to need to deploy updates if we're going to deploy any sort of query privacy mechanism to enable that. And we shouldn't have the that's sort of inherent to the problem space. While with sort of TLDs, et cetera, that's a little more, there's only one TLD operator of .com, and, getting them to change things is obviously a much harder thing than a software update to a recursive resolver.
Okay. Warren?
Hi, Paul. Would you mind going back a slide? I completely didn't understand your second bullet. So the name signal thing simply encodes in the name server name the fact that it does dot or something similar. It doesn't have the key there. So I don't understand why changing name server keys causes any issue.
So it either
I
has
suspect I'm wildly misunderstanding something.
So it either has a key or some sort of identifier that cryptographically binds that, right?
Nope.
So you think it's just an indirect reference, but so it points to something, and that something you have to keep up forever. So you cannot decommission it because you will never be able to get those records removed, right? There will always be customers that keep that record there.
Well, and I mean, that's currently true with name server names. If I change my name server name to something else, my customers don't know to update it. So yes, this does mean that once I've started doing,
yes, but they never hard failed on it.
Pardon?
So they never hard failed on any of this, right? If we're going to do a hard fail based on unexpected authentication or like different identities, then that could be problematic. You're right. It is a better mechanism than just storing the public key there. But I think it's still problematic.
Okay, I mean, I guess what it does mean is once you've turned on dot or doc or any of the other things and customers start expecting that you're doing it, you can't turn it off. But I think that that's the only failure. Or I'm misunderstanding, which I suspect.
Okay, Eric?
Paul. So I think you're making a pretty strong case that we need that whatever we define NAT to do now, we're going to be living with for a very long time. So I think that part I agree with. So I guess and if I can just summarize, I think if I understand your position is that you think we should put this information in the DS record. Is that a fair summary of your position?
It's one proposal that I think is worth exploring, and I just want to make clear for the people who might not have understood it. I think you can get a DS record at the parent without you yourself needing to deploy DNSSEC. And if we're looking at mostly TLDs, all the TLDs basically deploy DNSSEC. So it's not a requirement for the child zone to run DNSSEC.
Right, and thanks. That's a good clarification. I think that the properties of this signal, whatever it is, it seems to me have to be the following at least. One is it has to be easily propagated from the child to the parent. Two, it has to be only apply to this particular child if possible, not to every child with the same name. Those seem like the two most important properties. I think you're implying there's another property here too, which I'm a little less sanguine on, which is this bit about it being secure in the exact security properties you're indicating here. I guess the reason I'm not that sanguine about it is because, as I say, I think most of the information is being transmitted at this is being transmitted right here, which is to say, if I go to com, right? So I had to use com as an example. If I go to com, right, and I say give me example.com, and it lies so they can set up a tap, right? Well, I mean, it already knew I wanted to go to example.com, so it just you can just siphon that information up anyway. So I'm not as worried if this particular attack as you are.
No, because now you think you're going to go to a .com server that is on like evil.net, and you're going to authenticate evil.net and then give them the query for your example.com. So you are actually giving them all your privacy data.
But no, but I guess what I'm saying, maybe I'm misunderstanding you, but so I think in the case in question is that I'm going to .com and I wanted to reference example.com, and we'll say that the real server is example.net, but .com is going to divert me to evil.com. Is that your example? Maybe we should write this down because I think I'm getting confused. So I guess anyway, I am as I hope is clear, I am actually quite indifferent to exactly how this is spelled. So if DS works better than this name server hack, I'm perfectly fine with DS. And I think your point about the fact that the parent zones are largely signed is fairly compelling. I would prefer that to require DNSSEC, but given that I think most of the information is between the TLD and the 2LD, that seems it's largely would be probably livable. So I'm a little concerned by this discussion that I'm seeing in the chat about whether DS actually works, but perhaps we could actually investigate that problem in some way.
Okay, Victor?
Hello?
Go ahead.
Right. So I think to Ecker's point, I think Paul was actually assuming that there are some further labels in the domain name that you may not want to disclose to .com. Indeed, the second level is most of the sensitive data, but not always all of it. So sometimes the specific subdomain is sensitive and relevant. So to that extent, .com might still gain some additional information that they wouldn't otherwise. But DS indeed is far more viable than Service B, provided we don't try to encode keying information into the DS record that commits the name server to having a particular certificate or a particular public key. That's where we suddenly have the keys can never change scenario. Whether we put it in Service B or DS or wherever, we can only put very minimal signaling of some kind of authentication can be expected here, but to find the relevant key material, you have to go elsewhere. So one of the possible things you can put in the DS record is try and find the TLSA records for this and this record. If you find them, great. If you don't, well, too bad, you go unauthenticated. So that would be the simplest model, where DS signals the desirability of TLSA lookup, which you otherwise wouldn't want to do when most domains don't have them. Most name servers don't have them, and you would incur significant lookup penalties and maybe even lookup failures because some domains are stupid enough to drop TLSA queries or do various other unfriendly things.
But just to clarify, but if the SVCP content is basically pointing to a fully qualified domain name for a name server, then that could be WebPKI authenticated too, right? It's not.
In principle, yes. The new DS record, yes, can be an FQDN and an implied authenticated via WebPKI. I'm skeptical whether the DNS is a place where you can expect WebPKI to work reliably. In the browsers, when WebPKI fails, users interactively have various other options and various signaling to tell them exactly what went wrong. DNS is control plane, and when things break, they break in mysterious ways. And if I'm told to use some CA I don't trust, whatever. But that I guess that's an aside. So I don't think WebPKI is a good model.
Yeah, we have both the options, and may the strongest one win, or both, right? I just don't want to make sure that we're not excluding any authentication mechanism at all. Whatever was in the SVCP can be encoded in the DS record.
Yes, pretty much. You just have to make sure that you don't try and encode keys there. That would be a disaster.
Right. Thanks, Victor. Ted.
Howdy, could you go back a slide? I think that's Tim who has to go back a slide. Great. So first, let me just say that the DS hack sounds promising. I agree with Ecker that whether if we can get the reasonable minimal semantics in there, the fact that it's semantic overload and, as Peter Koch was putting in the chat, not good aesthetics. I've shipped uglier things. I can live with that. If it works, let's investigate that and see if we can get it going. But I also wanted to point to this and say that doesn't necessarily mean that this is going to go from 10 years down to no years. And I think what we've got to be a little bit practical about is it's okay if this takes a while. If we have, actually, I think I wanted one before that where you went through the EPP drafts and all of that. But if we have to go and write EPP drafts, if we have to go and persuade operators that they need to update how DS records are provisioned by clients in order to allow this to be provisioned, that's okay. We've all been involved in efforts that took more than 10 years at the IETF or longer. RTC Web, its BOF was in 2011, and I've got a meeting later tonight that I'm chairing, having chaired that original BOF. That's okay. What's not okay is looking at that and giving up, because then you never get there. If we give up saying we're never going to get there because it's going to take 10 years, rather than recognizing for things as core to the way the internet works as the DNS, yeah, sometimes it does take a long time, but you still have to start. And I think my argument here isn't do we immediately pick SVCB or DS. I think figuring out which one is the best one to go with and working that through is fine. But I really want to strongly urge the working group that even if it's 10 years, keep at it, because it may take 10 years, but it's still a major upgrade to get this done. So that's me cheering you on from the position of not currently a DNS operator or software provider, but a consumer of the results. So thanks for listening.
And one clarification: if the working group does that, please make it clear whether we're using SVCB as a glue record at the parent or as a new authoritative record at the parent, and argue which one's better.
Okay, Ben?
Hi, Ben Schwartz. I had to step out, so I missed some of this conversation, so I apologize if I'm on the wrong track here. So I'm obviously, I think that the name hack thing has some merit, or I wouldn't have contributed to writing it up. That said, I am also supportive of people who want to pursue a DS hack, essentially encoding this kind of information somehow in a DS record. I do want to push back against some of the arguments here. I want to essentially argue that the advantages of the DS hack are a little more limited than this presents. So first of all, the DS at the parent in this case is also controlled by the parent, just as the NS is controlled by the parent. So in terms of large-scale interception or interception attacks mounted by the parent zone is always in the position to mount that class of attack. So I think that's not really a difference between these approaches. Also, in terms of the amount of software modification required, I think it's important to note that CDNS key does not work here. You need CDS because what we're trying to inject into the DS record here is not a hash of anything. It's some arbitrary data. So we actually need CDS. We need the client to be able to inject that. And we also need new hash algorithm types for the DS record in order to be able to inject this arbitrary non-hash data into the DS. And that may require software updates. Also, CDS and CDNS key are far from universally deployed today. So I think it's entirely conceivable that there are going to be some zones where the DS hack is just non-usable, is non-deployable in some TLDs, for example.
So I think it's a fair point. Especially your last point, I agree with. Like the CDS might not be might not be as deployed as we hope it is, or not as well supported. I do want to again clarify the SVCB at parent. Its only additional function is that in bailiwick name servers can get protection. Everything else we already have without SVCB in parent. So we are talking about a really small part of the problem that we're fixing. A part of the problem that I think is unfixable anyway, because an in bailiwick name server, you're going to get a fully encrypted bunch of information, and then you're going to connect to an IP address of that, hidden name server name, and then everybody knows you're going to connect there anyway. So there's very limited value. Like I can roll out all of this on noads.ca, but sorry, there's only 10 domains there. So everybody already knows what is being visited there. Like I've already lost my privacy. And so this is like a lot of changes for a very small problem. And like, a 10-year project for a very small problem seems a bit like overkill to me.
So I do think that, one of the things that, one of the larger questions here really, for the chairs and such, is trying to understand what kind of an effort this is. And in my view, DPRIVE is a big change. It's almost as big a change as something like DNSSEC. And so it should be no surprise that we have to go in and really think hard about how the delegation system works and potentially add new records. So, we've added, in terms of new glue records, it started with just NS and A, and then, quad A was added, DS was added, and I think this is another one of those instances, and I think it's comparable in scale. So I'm comfortable with that, and I want to be able to move faster, and so I think we need some kind of hack. I think it's even conceivable that we're going to end up wanting both of these hacks, because they're deployable in different situations, because they have different properties. I'll mention one more thing, which is that if you care about protecting the second level domain, then as Eric has probably mentioned, you actually need your top level domain to be fully encrypted. You need it to be if you want fully authenticated encryption to protect the second level domain, the example in example.com, then you need the TLD to be doing authenticated ADOT. And if the parent is doing authenticated ADOT, then the name hack becomes fully authenticated encryption, as does ADOX generally. So I think worrying about authentication by DNSSEC in the parent is largely, I view it mostly as a lost cause. By the time you're relying on it, you've already revealed the label that you were trying to protect. Okay, I'm done.
This is Daniel Gilmore. So I like the DS proposal here, and I want to point out that if we do end up using this, it may well flush out bugs. We may find that there are bugs because of we're making a DS record that's not really offering DS. Any bugs that it flushes out are bugs that we would be seeing if we wanted to upgrade algorithms in DS anyway. And so there is a sense that if we do this, we are actually getting out ahead of other bugs, and we are prepping the DNSSEC infrastructure for the ability to migrate to a new algorithm suite should we need to. I think that most of those bugs have already been flushed out with the kernel work, but I'm just saying that if running into these bugs in this case would actually be healthy, and I don't think that's a problem. The second thing that I want to identify is that, and I apologize that I'm still a little bit fuzzy on this. So I agree with earlier speakers who have said that this signal should really only indicate a couple of bits, like hard fail or not, and what particular mechanisms we expect to be available. That is, hard fail or not based on authentication, and what mechanisms we think should be available and should not indicate keys. But one thing that is still a bit of a gap in my mind is whether we think a signal that's stored in the DS would be a signal related to the entire zone, or a signal that is related to a specific name server of that zone. That is unclear to me here, and I think that there are different impacts of deciding it in different ways, and I invite people to speak up about what they think there. I don't really have a fully formed understanding of what the trade-offs are.
Okay, so a couple things. I'm gonna cut the mic line after Paul Hoffman, and I'm just going to, maybe for DKG's benefit. I mean, we've talked about whether we want to do per server or per zone authentication and encryption. So that is an open topic that needs to be worked through. Next in the queue is Eric.
Sorry, Brian, just to clarify, I understand that we've talked about that. I'm saying that for the DS proposal, it's not clear to me how it would work. Like, I think I see how it would work in the per zone mechanism. I don't necessarily see how it would work for the per server mechanism. You'd have to have like multiple DS records that are somehow coupled with particular NS records or something like that.
Yeah,
I don't see how it would work.
Yeah, I just mentioned that it's an open issue. I don't think we have solutions going yet that would address like your concern there. So just agreeing that it's an issue that we need to consider. Eric.
One thing I've been wondering is whether we need to, like, it seems like there is a bunch of jumping directly into implementation solutions without necessarily writing down exactly what all the requirements are. So I think there are cases here of saying this won't work because of these requirements, this won't work because of these requirements. I think that we might go a long ways from actually writing down enough of what some of those requirements are. Because I do agree with Ted here that we should ideally be looking for something that's a long-term solution, even if it takes 10 years to go there. And ideally, if one of the requirements may be seeing if there's an incremental path that allows us to get the 10-year security properties we want, but with incremental deployment that doesn't break our ability to get there in the long term. One potential path around this is, which is expired now, but draft T-April NS2. It has some similarity to Ecker's draft, but spent a bunch of time thinking more about some of the deployability issues and how it would work with parent zones. And in particular, one of the things that it did was the SVCB record equivalent, which in that case was NS2, that lived in the parent zone, was typically not a service mode record, so it didn't actually contain the keys itself, but would generally, if it was in a parent zone for TLD, would be an alias mode record, so that the actual keys could live alongside the name server name. Because I think that's one of the properties that is going to be important, is making sure that the key all of the configuration on keys, as well as all the configuration on name servers, lives along with the name server and the owner of the name server, not with the zone along with the zone.
All right, thanks, Art. And the one thing that you said there that has been a kind of a point of frustration is the requirements discussion. We've had a document to try to do that. We weren't getting any kind of input on it, so we're kind of going in circles here. So the working group's going to have to figure out what they really want to do in order to identify what kinds of solutions they want. Brian, you're next.
In the chat channel, I've been kind of dominating the discussion. I thought I'd clarify the DS proposal I've been talking about. I'm going to write it up, and I'm going to do it in DNSOP. The main characteristics of it are that it would be a new DS algorithm. The content of the record would be a concatenation of the NSR data for the child zone, but that is simply linked to the NS records, which are independent of the child zone itself. So all of the characteristics are tied to the authoritative server, and by just joining the R data and then hashing it, you don't need a new hash algorithm. You only need a new DS algorithm, and it would not be tied to the child, the actual zone itself being signed. The absence of or this being a very specific algorithm would be the exception to the child needing to have a DNS key and indicating that the child is signed. It would be orthogonal to normal DNSSEC. It would simply be a way of putting data in the parent that is something that would be authoritative in the parent and signed, because that's what DS records have as a property. It's on the parental side of the zone cut, but it's it's basically protecting via hash and signature the NS records of the delegation, and those would be directly tied to any changes to the NS set. So the downside of that is obviously you have to get that into the parent zone, which currently would be EPP, but it being an existing path would not require the TLDs or the registries to do any work other than permitting the new algorithm. So I hope that has explained that it's not tied to the child zone, it's tied to the name servers. It's based off of the name server's actual R data, the NS records R data. So it is based specifically off of the names of the name servers, and would be possible for the registrar, whenever it sees a change to the NS records, to make those changes, submit the updated DS records. And that would allow authenticated validatable NS delegations, which is what's missing currently in DNSSEC generally, and is a requirement for jumping over the parent to child piece.
Okay, Victor.
So I want to say that with the NS signaling clarified to not carry keys, I'm more sympathetic to it if it just carries a couple of bits of data signaling a mechanism. Then it's roughly equivalent to DS, modulo the fact that we don't have parent signing of NS. And so if that's desirable, then we have to look at the pros and cons of DS is signed and NS isn't, and what's exactly our threat model. And we can look at that, I think, after the meeting and debate the fine points. But otherwise, the two are both in a much better adoption probability space than service B. And there are just minor differences between NS signaling and DS signaling, mostly around the integrity of the data if your connection to the parent is not encrypted and authenticated. Of course, that, as Ecker observes, brings its own issues to light. And so there we are.
Okay, thanks, Victor. Eric?
Hi, video. Okay, yeah, I'm trying to figure out, like, honestly, what the way forward is here. I guess I have, I think, three hopefully very quick points. First is, I think if we were to do, if we were in fact to change the unauthenticated in the way that I indicated in the email I just sent, the proposal I sent on the microphone earlier, then I believe that that would get us a fairly large part of the way there. And I think if you believe Paul's analysis, which is that the important thing is it actually that covers many of the cases, that because you'd cache the information, then actually maybe you'd be quite far along. Second, I think that there is some need to flesh out the threat model about whether or not we believe that the cache for the recursive, for the authoritative that is being delegated to has to itself be hot. Because if it doesn't have, because we've been assuming that it was cold, which meant you had to get the information that was encrypted when you looked at the parent. But if you sort of think of it the way Paul was indicating as sort of like an HSTS kind of thing, then maybe you could live with it being cold, being cold initially, not getting encryption, then revising up to encryption. And I think I think that'd be helpful to flesh out. And the third thing I think is, if we could agree on the information set that was in this value, then perhaps we could debate exactly how it was propagated to the parent separately, or delegate that to some subteam to figure out. I think the information set that's in our draft is roughly correct, even if it's being spelled in the incorrect way. Thank you.
Thanks, Art. And Paul.
So super briefly, if the working group goes towards, for this use case, goes towards DS, Peter and I can actually change the signal that we're using to being some sort of like new record type of DS and child that has exactly the same information in the same format. So that goes back to the desire that people have for us to be having things in the same format. And then that might even fix the CDS problem where it's like CDS for which and stuff like that. Is it could be that we just come up with this new child record that has just the bits that we want, as described before, and that gets copied into a DS in the parent. So we're totally open to that. And if that helps the working group move forward on both drafts, all the better. Thanks.
All right, thanks, Paul. Victor, make it really, really quick. If you're talking, Victor, we can't hear you.
The DS record in the child is unnecessary. CDS plus a new kind of DNS key algorithm, as suggested by Brian Dixon, would do the job. So even CDNS key would work, provided that the data that's published in the parent were in fact a hash that would do the right signaling. It wouldn't need to be in the clear. The algorithm would indicate everything you need to know, and the hash would just authenticate the name server names, making sure that they're not tampered with. So there's lots of space.
Victor, we were offering that in case the working group wants more parallels, and we're not saying it's a better solution.
Right. So anyway, there's a bunch of room in the design space. There's more than one thing we can play with. I think service B is the least likely to get there in a reasonable manner, but the other options have some credibility.
All right, thanks, Victor. So we are over time. Tim and I are going to, there's a bunch of topics that are going to need some engaged work group discussions. So we're going to go through the various points that have been raised and try and start kicking off discussions on the mailing list so that we can kind of flesh these out. If people have particular topics they want to make sure that we cover, please let us know. And if you have proposals like Brian Dixon that or similar type approaches that you would like the work group to consider, please consider documenting those and thinking about what's the, as Eric as Ecker was saying, things like what's the threats that you're addressing, and what are the implications on the operational side of the world. That would help us keep things moving in the working group. With that, we'd like to thank you for participating in DPRIVE at IETF 111, and we will see you on the mailing list. Thank you all.